Scientists astounded as new hidden world discovered inside Earth's core. Scientists studying the inner workings of the planet were astounded to discover a new hidden world deep inside of the Earth. The groundbreaking discovery has challenged decades worth of accepted science about the Earth's solid inner core. Earth's inner core, the innermost of the planet's layer, is understood to be a mostly solid ball of iron and nickel measuring about 760 miles, 1,220 kilometers, across. Found about 3,200 miles beneath the Earth's surface, the core is responsible for generating the planet's magnetic field. Since the 50s, scientists have generally agreed the inner core is solid and surrounded by a layer of liquid metal. But according to new research published at the University of Hawaii, the solid core might be a lot mushier than previously suspected. A team led by Rhett Butler, a geophysicist at the University of Hawaii at Manoa School of Ocean and Earth Science and Technology, SOEST, has found the core appears to be a mixture of soft, solid, and liquid materials. This mix of materials extends across the top 150 miles of the inner core. To date, scientists have only been able to reach the planet's core thanks to the magic of Hollywood. The 2003 disaster film The Core, for instance, saw a ragtag team of explorers drill to the center of the planet to kickstart the core with a series of nuclear explosions. But the pressures and temperatures experienced at the Earth's core are far too great for any machine, let alone human, to ever visit. Instead, Dr. Butler and his colleagues studied the core's composition by analyzing earthquake waves. He said, illuminated by earthquakes in the crust and upper mantle, and observed by seismic observatories at Earth's surface, seismology offers the only direct way to investigate the inner core and its processes. As the earthquake waves travel through the planet's multiple layers, their speed changes and they may reflect and refract depending on mineral compositions, density, and temperatures. Dr. Butler and his team collected data from the core by tracking these earthquakes from direct opposite ends of where they were detected. They then used Japan's Earth Simulator supercomputer to assess 5 pairings: Tonga, Algeria, Indonesia, Brazil, and 3 between Chile, China. Dr. Butler said, in stark contrast to the homogeneous, soft iron alloys considered in all Earth models of the inner core since the 70s, our models suggest there are adjacent regions of hard, soft, and liquid or mushy iron alloys in the top 150 miles of the inner core. This puts new constraints upon the composition, thermal history, and evolution of Earth. He added, knowledge of this boundary condition from seismology may enable better, predictive models of the geomagnetic field which shields and protects life on our planet. The study was published in the journal Physics of the Earth and Planetary Interiors. The findings will help scientists better understand the dynamics of the inner core region, as well as the processes that generate the planet's magnetic field. The researchers plan to use the Earth simulator to model the inner core in finer detail and compare the results against the geomagnetic field. Jessica Irving, a seismologist at the University of Bristol, who was not involved in the study, told Live Science, "The more that we look at it, the more we realize it's not one boring blob of iron. We're finding a whole new hidden world."